Welcome to the course on how computers work. Before we dive into the details, let's first look at the big picture. A computer can be thought of as three main components. A computing device that handles calculation is no different from a simple calculator. A memory device for storing results, similar to a piece of paper. And a control device, similar to an administrator, responsible for moving numbers around. The computing unit is connected to memory unit through bus in order for the numbers to move around. Users tell the control section what to do by using instructions. So here's a place for users' instructions called instruction register. It's fed into the control unit. To get instructions here automatically, users pre-store all the instructions in these smaller memory units. Instruction register is connected to accept them. Since there are many units here, you use memory address to pick the right one. So there's a unit called memory address register for holding memory address. Memory section takes in this address, selecting the right unit, allowing it to output. To get the next instruction address, we need to compute it. So there is an instruction address unit called instruction pointer, used for computing the next address. It's connected to the bus in order to move in or out the computed address. Memory address register is also connected in order to take in the computed address. Initial data is also stored in memory. But in order to access these memory units, users need to compute their addresses. So there are some additional units for holding temporary data. They are called registers. Some are for computing the data addresses, some are for housing the real data. Now, how does the control unit do all these things? Well, it sends signals. The instruction pointer has the first instruction address. The control unit signals it to let it out, then signals the address unit to receive it. The address here selects the right unit. So once the control sends the signal to release it, instruction gets out. The instruction unit is signaled to absorb it. To get the next instruction, control unit sends the current address to the computing side, increase it by 1. Signals the instruction pointer to take in this new address. The instruction fetch cycle is done. Now we have the instruction here waiting to be executed, and the next instruction address here. Then the control unit will execute the instruction. After that, the cycle repeats, fetch and execute. But how to execute the instructions? Let's first figure out what needs to be done. The control unit needs to signal the registers to receive and send data. It needs to signal the computing unit to do the right operation and signal the memory unit to receive results. There are several different instructions for different purposes. So we want to move initial data into the registers here. Instruction tells the control unit which one to receive the data. Control unit signals it to let data in. If we want to do computing, we use a computing instruction. It tells the control unit which registers to let data out. Once the numbers get here, control unit picks the right operation. Computing unit spits out the right result. But wait, how do all these work exactly? Like, how does the control unit understand the instructions? How does the computing section know how to compute? And what do you mean by signals? And what are these boxes anyway? Okay, addresses, instructions, numbers are all electricity sitting in memory units. They are controlled by two switches. One can be turned on by electricity to let electricity in. One can be turned on to let electricity out. So now to do things, control unit only needs to supply electricity. That's the signal. How to do that? Control unit is a big switch, made up of many smaller switches connected to each other. These switches are controlled by electricity. When you first power on the machine, there's a switch that automatically turns on, providing electricity to the next switches and the next one, turning on instruction pointer, letting electricity out. Then turn on the next switches to let electricity in. This is how control unit moves instruction address. Once electricity gets here, it turns on switches after switches, who will eventually turn on the right memory pairs to move electricity instruction over. Instruction is also electricity. They are wired carefully to turn on switches after switches, who will turn on the right memory pairs to move electricity numbers over. The computing unit is also a big electricity-controlled switch, made up of smaller switches. Once electricity numbers get here, they will turn on/off these switches inside, spitting out the right electricity results. So that's how computers compute. All these switches are made up of this tiny semiconductor device, transistor. It's an electricity-controlled switch. Turn it on, it's a conductor. Turn it off, it's an insulator. Put it into a power line, it's used to control electricity. You combine many of them to make bigger and more complex switches. So a computer is made up of transistors and wires. You use electricity to control. So how computers work? Switches turn on, switches turn on, switches. Even more questions now? Let's begin our journey to find the answers.